Since apparently our announcer is missing, I have nothing to do than introduce myself. My name is Vanja, and I work for Cisco Talos as a security researcher. And so at this session, what we'll try to answer a question that I posed to myself during this research, which is, are some of the executables we use in Windows legitimate tools, or they're actually weapons of mass compromise? So I'll cover some of the area just to see from you what you can expect from the talk, what's the motivation behind it, and a little bit of a context. I will talk a little bit about which are the binaries that are misused by malicious actors and red team members as well. And then I'll talk slightly about the process that I took to investigate and do some of the research. And then the results, like some of the more interesting finding of what it is that we found by investigating the data that Cisco Talos, which is Cisco's threat intelligence operation, has in its own kind of data source. Okay, so let's start with the context. So I come from the anti-malware background and threat research, and most of the times when we, even like a few years ago, when we talk about some of the most interesting compromises and some of the most interesting attacks, we would say 80% of them will be introducing some kind of malicious code. And when we talk about malicious code, we would always think about there are actually files. So you have an executable file and you run it. And over time, we slowly saw a shift, or at least there was a claim that there is a shift from just malicious binaries to malicious actors and hackers or attackers misusing the existing Windows executable and system files. So what's the idea behind it is that even if you have like anti-malware software or some kind of process, it would be more difficult for you to detect the illegitimate activities if everything that's used, like from the point of compromise to the point of the realization of the goal for the attacker, is used using standard executables. So it leaves minimum footprint, is more difficult to discover, and what we did is we mostly investigated on Windows, but the same idea can be applied to, of course, to other OSs. And in fact, if you think about some of the old OSs, so these executables are also known as living off the land binaries. So, and I don't know if I see that most of the people are here a bit younger, just a bit. So I can ask you, this is a little bit of a quiz, and to see just if anybody knows what this is. Yeah? I know, Cost, you will know what it is.
Assembly.
Yes, it's assembly, but it's a particular type of script. So long time ago, in some galaxy far away, there used to be this operating system called DOS, or DOS operating system. And so this just shows that the idea of having these living of the land binaries, but to hide the malicious code, is not completely new. So what this is called a debug script. And you could actually use this kind of scripting language almost like an assembly. So you have the first command to set the name of the file you want to write to. Then you say, I want to assemble a certain instruction from certain address. And then you put the instruction. So this basically is a code to set up a BIOS data region and then jump to BIOS data region, which will cause the machine or computer to reboot. So basically this is just the code to warm reboot of the system. So this was what the malicious user used to use, well, some time ago, but not just simply by rebooting, but using some kind of malicious things in those times. Therefore, it's not weird that we also expect to see similar thing in new operating systems. So the whole idea is, like I said, living off the land binaries, and if we can use signed binaries or misuse them, the better it is, because we think that the signed Microsoft binaries are legitimate, but they often have some kind of unknown or unwanted side effects. So what we're talking about is mostly things such as PowerShell or command execution mode, scripting interpreter, some of the other utilities which are present by default. And they can be used for various things, such as downloading the malicious code, executing the malicious code, bypassing various whitelisting mechanisms, such as the ones that are built in Windows or not, user account control bypass, adding new users, and so on. So everything that can be done by a system administrator using those legitimate tools can be done by the bad guys. It's worth mentioning that we can think of these living of the land binaries not only as Windows or Microsoft signed, but almost any kind of signed binaries. In fact, you have manufacturers of laptops, and they often install their own applications, drivers that are used for the particular computer, and they can also be abused. In fact, there was recently a case, I think that I think it's one of the manufacturers who used WinZip or RAR with a different name, signed with its own. So even if the RAR was not installed in Windows by default, on that particular model, on that particular vendor systems, you can always depend on that executable being present. So that can be used for some illegitimate purposes. Of course, with living of the land binaries, you can also have a pair of that works very well with some of the legitimate websites, which can be used to either download malicious code or upload the data if the attacker's target is to exfiltrate the data. So GitHub is, of course, a repository that's used for the source code for a lot of the open source and even closed source product, but there's nothing to say that the malicious code cannot be hosted. Or even the legitimate code, again, can be misused by downloading it and running it in memory from GitHub, and we'll see that in some of the examples. Then, of course, Amazon Web Service, Google Drive, everything that you expect from the ordinary users to use in a day-to-day operation. This is what's actually used by the attacker to try to hide their own activity. So if you have a network administrator and they look at the network activity logs, it would be very difficult for them to distinguish which are the legitimate operations, the legitimate users, and which are the illegitimate. Because on the first, when you look at it, there are no differences between, there's no like anomalies that you can point to. If you want to know a little bit more about this idea of living of the land binaries, I would suggest you to look at the two things. One of these is MITRE attack framework, which stands for Adversarial Tactics and Techniques, Common Knowledge. It's a database of various tactics, tools, and techniques, and even groups, which you can recognize by using a certain set of tools. And every tactic has its own number, so when you find some kind of system evasion, you can refer to a particular tactic. It's very useful. And then there's this LOLBAZ project, which is a living of the land binaries project, where this researcher Odvar Mo, who basically maintains this repository on GitHub, puts all the new executables that can be misused, but also how you can misuse them. So it's a very useful project. So I'll talk a little bit about what kind of data source I've been using in the last few weeks or a couple of months, maybe even, to try to see whether this idea of living of the land binaries is in fact true within all of the users that are using some of the Cisco security products. So what we have is something called TIP, which is short for Threat Intelligence Platform, and it's basically a Hadoop file system, and we store most of the data in Parquet file format, where we collect telemetry from various Cisco's products. And I was particularly interested in something that's called Cisco AMP for Endpoints, which is a advanced malware protection for endpoints, where besides of detecting malicious code outright, it also logs command lines which are executed on systems that are using or having installed this product. So the idea is that antivirus software or anti-malware won't be able to prevent everything that comes into the organization. So when you realize that something going on, you can go back in time in your console, and so from then on you can see exactly what happened by investigating this sort of line of command line execution path. So we don't only store command line execution command lines into this big data lake or data platform. We also look at the DNS requests. So we have a large and set of DNS requests because we have one of the DNS resolvers, which was previously owned by OpenDNS. We have about 150 billion DNS requests to investigate every day. So it's quite a large set of data. We have some other various telemetry from intrusion prevention systems, from network firewalls. Of course, Cisco is famous for that. So everything is kind of allows us to do, but in order to have queries that will last minutes or hours rather than days or weeks, you need to have a pretty good platform, a pretty good idea of what you want to look, how you store the data, and it's a big cluster of machines that allows us to investigate these command line actions. This is just the idea of shows the idea. For example, if you get an email and Outlook is running, Outlook will create a file. So as soon as the Outlook creates a file, we will get, or the administrator will get notified that the Outlook has created a new file. So that file can be named photo.zip, and if you Explorer.exe extract it and run it, you could see that photo.exe was executed. And then photo.exe can contact the website, or you can drop another file, or you can create some kind of system change, and everything that can be seen by the administrator. Some of it can also see by our own team. And although the data is very much anonymized, so I don't see who that is, on large scale I can basically look at those 10 billion command invocations on a daily basis. So quite a large data set. And here's my kind of more or less hunting process. Every day I would run certain queries in Hadoop using MapReduce jobs. And so I would distill that 10 billions because it would be impossible for me to look. I would look for some kind of interesting stuff, and then I would look, and hopefully at the end there'll be profit for me because I'll see really what happened and whether I can confirm that the Windows binaries are used or misused in a way. So some of the hunting tools I have is the Spark framework that allows you to run MapReduce job quickly, and things such as Python Spark or PySpark and Spark SQL, which really allows you to declaratively specify what kind of data I'm interested, which data I want to extract from all of the logs I have. So this is just an example. In my case, I have a whole command line. I also have a unique machine ID. I have a unique organizational ID. I have files or cryptographic checksums of the actual file that got executed and its parent, so I can create this sort of chain of parent-child. And I also have the full command line. So argv is the argument array of all the arguments that are added to the particular group. So now that I have this, when I run it every day, I distill that data to about 4 million unique kind of records for the day. And from then on, I start doing all sorts of grep, sort unique, to kind of eliminate things. So everything is, what I've done is very manual. Everything can be automated, but for the purpose of this presentation, I kind of use it like that because, I don't know, I just felt like I had things in control and I can change these queries on the fly, because if I see that I'm getting too many of the certain types of results, then I can simply include them by using grep -v, which is just say I don't want these particular ones. So I targeted about 20 different executables which are regularly installed on Windows to see how many of them are executed and how many of them, hopefully, I can confirm they were executed with some kind of malicious purpose, or we have attacker, the real attacker behind them. I won't go into every single executable and how it's misused because that would be too boring, but I would refer you to this Living of the Land project, which kind of has the cross-reference between those binaries and how can they be misused. So I'll talk a little bit about findings. So first of all, in most of the attacks I found, and it was also very convenient for me somehow, sooner or later you will reach the attacker or malware using PowerShell. PowerShell is installed by default. It can be disabled. Unfortunately, there are quite a lot of the legitimate tools and frameworks which are also using it, so it's a bit difficult. You can also set a group policy where you can say only signed scripts can be run. Good thing for PowerShell attackers is that you can simply use a command line bypass policy to bypass that policy, and you can immediately run the malicious code. So there are so many different modules that can be used that are also used in legitimate purposes, and basically it's a very powerful framework which sits on top of the .NET framework that allows you to create scripts. And in fact, it was its initial use from the point of view of Microsoft was to allow system administrators to run those one-line codes to do a little bit of administrations. They didn't even, I don't think that Microsoft ever thought that you will have scripts with tens of thousands of lines of code, which will allow malicious attackers to load code without actually running it or using some of the standard Windows APIs. So you can obfuscate code. There is also very annoying flexibility with command line options. So for example, if you have a command line options that should be minus encoded command, which allows you to set a parameter which is encoded at base 64 and which will be interpreted by the PowerShell interpreter, you can also specify minus enc, minus e, minus encode, minus whatever, because PowerShell is so clever that it will understand what you wanted. So for me, it was a bit tricky to say minus e. I know on minus c and minus this, but it's very difficult from all the noise to find the things that I'm interested in. So I looked at the kind of PowerShell invocations that may be interesting or malicious, the ones that will, in the command line, have strings such as IEX, which is invoke execution, any invoke, any bypass, or hidden. So I looked at those particular four with PowerShell. And once when I had that list of executions or list of PowerShell starting, about 2 million every day, then and I could find those more interesting ones. And then I realized that about 1 in 1,000 of the ones that I thought that are suspicious are actually probably malicious, or there's some kind of actor behind it or a red team behind it. So it's still worth to then think, if you are working in a security operations center, that although those binaries are abused, majority of the command line from PowerShell, or in fact any of the Windows executables you see, will be still legitimate. So yes, they're being misused, but a lot of it is. However, if you also have living of the land binary and you see some kind of URL in the command line code, then there's a much higher probability that this invocation was in fact malicious. So this is what I kind of try to use, especially even if there is like an external numeric IP address, most likely a bad .NET domain, top-level domain, .eu top-level domains, most likely. So these are just like a guidelines to, if you're working in a security department of any company, that you can basically try to monitor. And PowerShell by itself, although it's very useful for the attackers, wouldn't be as useful if it wasn't for a large number of PowerShell frameworks which are used and have been seen in this kind of little research I've done, starting from the most commonly seen reflected DLL loader, which allows you to essentially take any executable or any DLL and loads it in the process memory either of PowerShell.exe or some other process without using the standard load library, get procedure address API calls, which may be intercepted and detected by some of the endpoint security software. And so starting from there, there are like many almost legitimate tools available in Github, most of them, which are then used by PowerShell. So what happens with the PowerShell, you have this invoke web request. So when you invoke web request, it downloads the actual code, and you can from then on, you can say invoke execution of the code that you downloaded. So in fact, you don't have anything on the disk. So anti-malware or classic anti-malware, it would have a difficult time to detect this code, but you have everything in memory. So this is the sort of idea of memory only or so-called fileless type of malware. The other thing that I've realized that there are a lot of companies using various red teaming or adversary emulation frameworks, such as Red Canary atomic tests or something called Simulate, which I didn't know before, but now I know that it's used as a kind of legitimate tool to test that your internal team can see that, that there's something bad going on. So here's just an example of one of the kind of custom-based, let's say Mimikatz is one of the tools that's often used to steal credentials from memory. So this is an example of the PowerShell code where somebody was simply just obviously using a red teaming, and he said you shouldn't run invoke Mimikatz without express written consent from client. That will be written on the screen. And then they said that Benjamin Delpy, who actually created Mimikatz, is a funny guy. All right, fair enough. So a lot of these tools on the PowerShell. So I'm just mentioned a few other tools that are more likely to be malicious, or at least they are good for me because I can see that they've been invoked with a URL, and then I can investigate URL. In my case, if the PowerShell is invoked with the actual PowerShell script file, but at least my software, it will not allow me to see what that file is. So I only know that there was a certain file name. So with some of the other programs I wanted to investigate, I had more difficulty into realizing which code is legitimate, which code is malicious. So 4 of these, if combined with URL, almost certainly there is some kind of malicious code running. And so we have some other limitations which I mentioned, some other executables such as C# compiler that's built in, or Microsoft equivalent of make called MS-build. I only get the file name that was used as an input. So I know that they are misused, but I can't really measure of how often they have been misused. So now I'll go into a few of the case studies that were a little bit more interesting, I guess, which I stumbled upon by investigating all these logs. First of them is a coin miner. There are so many of them that I didn't really want to name, or didn't really bother to name the campaign when they looked for it. Of course, the idea of coin miners, which are the ransomware of the new day, is that it makes some money for the actual attackers. And there are like from script kiddies to very organized groups. I stumbled upon a group that's called Nugget Phantom. It's a Chinese group that uses all sorts of difficult tricks to hide its presence on the system. And these guys I also managed to find them, but this is a little bit simpler example. Again, like I said, I'm investigating command lines as they happen, and I stumble upon something that looks like there is a base64 encoded command for PowerShell. I decode it, and then from then on I can see that something is trying to load or actually decompress a stream from memory that's been base64 encoded. So once when it's encoded, you can see that some of the code that you get from there is very much obfuscated, and the code is not very easy to read. So here there is a special module for PowerShell that's called invoke obfuscation, and you can use it as many times as you like, and then the actual code will be enveloped in this sort of gibberish, non-understandable, not properly readable code. So you have to be able to strip this code first, and in this case of this particular coin miner, there were maybe 5 or 6 different levels. So here's another level, and then finally when I deobfuscated all the code, you could then get to the actual code of the coin miner, and in this case you could see that it downloads a string from a particular location, parses that string, and then based on the content of that particular string, it will try to steal the credentials from the local machine using all these legitimate tools that I mentioned. Empire project that's used by some of the red teams. Kevin Robertson, another security researcher, has something called invoke the hash, which is again used to try to steal the hash of a password. And once that's done, then the coin miner will try to start to spread around the network that's infected, and based on that initial file, if the first parameter is 1, it will try to spread using Windows management instrumentation, and if it's 2, then it will try to use SMB spreading with the stolen credentials. So we here see that this is a coin miner, or at least its PowerShell part. That tries to, once when it's inside the network, it tries to steal the credentials and then pivot around the network to infect other machines, therefore to increase its own mining pool and have more probability to generate some cryptocurrency, and most of the times it will be Monero. So the final executable, which depending on the bitness of the operating system, will be called something System32 or System64, is a variant of a free coin miner called XMRig, but it was changed so it also has a control center with the idea that all the systems will connect to the console, and then from the console you are able to give various instructions to the coin miner. So that was the first case. The second case is Cobalt Strike, which is another framework that's almost as often used as Metasploit for post-compromise. So once when we have systems running on and infected, then in that case we can install this Cobalt Strike, and then it's used for post-exploitation techniques. So in this case, again, we had a PowerShell at the beginning, and that PowerShell had some base64 code. That base64 code will be decoded, and then a new job will be created. A new job which is an actual shell code, so a binary. So it allocates an area in memory, puts that decoded code in memory, and then jumps to it. And here we see like a standard x86 executable code. The part in the middle is probably just the data, and I took a screenshot just to illustrate some of the strings that we see. We see 1111 jQuery.js. We know that jQuery is one of the most popular JavaScript frameworks, so libraries, and almost any page on the web sooner or later will download jQuery. And here down below we also see HTTP headers that have two fields. One is the referrer, that's code.jquery.com, and host code.jquery.com, which is the legitimate website which hosts jQuery. However, this shell code uses like an IP address, and it sends a modified HTTP request with those headers. But when you look in some of the automated execution environments, some of the sandboxes, you could see that it managed to fool some of the DNS request resolvers from from those sandboxes. So you could see that the domain is code.jquery.com, but the IP address is 134.209.176.24, which is the attacker's address. But the system still thinks it's a legitimate jQuery website. So it's one of the techniques that's used to evade the detection in sandboxes. This is taken from a different sandbox, and again, we see that the sandbox is thinking this is a legitimate website. In fact, it knows it's an IP address that's kind of not used, but code.jquery.com is legitimate. So when I looked at what it is that's hosted on that IP address, you could see that it in fact starts with something that looks as a JavaScript and in fact is a beginning of jQuery. And then suddenly after this P equals in the third row, we have a number of binary characters. And then also at the end, when the binary characters end, which is about 300 kilobytes later, we have the end of jQuery. Again, idea here is that the file that's being downloaded starts with legitimate code, then you have the binary or something that's probably not right, and then at the end, if the anti-malware software is scanning top and tails, which sometimes happen, it will then think it's a standard JavaScript code. So when that was decoded, in fact, that hosts the Cobalt Strike beacon, which is this sort of Trojan that allows you to do all sorts of post-exploitation activities. So in this case, I really don't know who's behind it. I can't do much more except to say, compared to the coin miner, people behind the coin miners, this is a more skilled attacker behind the Cobalt Strike, because they take care of trying to hide their presence and trying to hide the fact that they compromise somebody's machine. So we have when I say regional, this is not an example from Serbia, but it's an example from a country neighboring. I'm from Croatia, so it's a neighbor country of Croatia. And it started with a Super Mario game installer, or at least there is this sort of free version of Mario game that can be downloaded, and many people like the Mario, and this is like a DOS emulated website that allows you to kind of download this page. So somebody, and this is in Slovenia, downloaded this Super Mario installer. They modified it to include some malicious components, and somebody from quite a large company in Slovenia downloaded this installer, and they actually launched it, so I could see some of the activities. And in fact, I was able to retrieve again, you remember PowerShell code will sooner or later kind of happens in this sort of chain of infection. So the game installer was called Mario Game Installer.exe. I wasn't able to find it. So I don't know where the attackers hosted this. I wasn't able to find it mariogame.exe, which is the actual dropper for the rest of the components. I found mario.exe because it's a copy of Netcat for Windows. So when the attacker is exfiltrating some of the data, they are using this mario.exe to pipe that data to a remote site. So they're using that for exfiltration. And the other part with the exfiltration is they're using a Gmail account, which is, to me, with the hard-coded credentials. So not very clever on the attacker part, because if it's their own account, then it's a bit stupid. But even if it's not their own, then the Gmail or Google can simply blacklist that email address, and the whole operation is compromised, because then you're not able to exfiltrate the data. So for them, it would be much better if they had that email address and password somewhere in the cloud where they can change it under their control and then download it first before using them. But nevertheless, so we think this is the level of whoever this is doing is not very high, so it's likely some kind of script kiddie level guy that downloaded quite a lot of the code from this GitHub page Orions, and just modified it with their own little domain. So here we have some of the domains, magiclight.se, where they downloaded those 2 PowerShells that actually are conducting the malicious activity. And once when the malicious activity is conducted, then we can also see that they actually have like hard-coded network credentials for Gmail, and then they're sending with a subject that's a prickly cactus quack quack. Is the subject of the message for the attacker to actually read the emails or some of the data that's being retrieved. So here again we'll see the staging script that basically sets up some of the, collects some of the data and saves some of the data into a text file. And that text file is then executed. So the next stage of PowerShell, so the 3rd stage of PowerShell is executed, and that's more or less stock code from this Orion's repository. And that stock code collects as much as information as possible from the affected machine, saves it into a file called path.txt, and that path.txt is uploaded to that Gmail address. So this is kind of a, I included it because it was a regional compromise. And then the last kind of set of things I have to talk about, which we also publish, is called China Chopper. It's not necessarily a living of the land binary, but through investigating China Chopper compromises, we managed to find quite a lot of the real attackers using command line execution to misuse some of the Windows binaries. So what is China Chopper? It's a web shell. So if you're able to compromise a website or a web application, the only thing in PHP, for example, you need to do is include like 20 or 30 bytes of code, PHP eval post, and the variable you're going to use to send the rest of the code from the client side. And here you also see the user interface of the client, which is then click and point and click, very easy to use. And it's one of the kind of frequently used tools by some of the Chinese attackers and groups. But it's been present for about 9 years and not very much changed since the beginning, but it's still being successfully used. So my motivation behind trying to investigate China Chopper was there was a news about a number of telecoms around the world compromised, and the researchers from CyberROM who initially investigated those incidents also said that one of the tools that's been used was called China Chopper. So I looked, what is the traffic pattern of the China Chopper? And then I realized that I can, because I can look at all of the command lines, when the attackers start remote shell with the compromised host, China Chopper suggests this command, netstat.-an pipe to find established. So tries to find established network connections. So it suggests that, and most of the times what the attackers do, they just press enter. So this is like a clear sign that a web application or a host is compromised with China Chopper. It also has one other strange characteristic, is that it puts start and end in brackets almost at the end of the command. So you can really make a nice regular expression pattern to detect China Chopper activities, which allowed us to find many organizations that have been compromised, starting from some of the simpler ones to quite like government agencies. For example, some of the Asian governments have been compromised with China Chopper. So here we see, like, on the server side, we only had that one line of PHP code, which essentially cannot do anything. But on the client side, when it creates this request, it says test equal a big blob of data, and it sends about 2 or more variables. So the first variable is the code that handles the rest of the code, and the other ones are parameters for that code. So if I want to run a command line, then I can say, well, look at the parameter 0 and look at the parameter 1. So when it's decoded, and you could see that some of it is base64 decode, you can see that it looks at the, so parameter 0 is the actual code that handles parameter Z1 and Z2. Z1 is the executable I want to execute, in this case command, and Z2 is the command I want to execute, which is cd in the directory of the compromised application, and that net-an pipe find established. So I can see all this in the network traffic. And I chose from the quite a few we've seen, I chose like 3 to document 3 cases. One of them is the cyber espionage case on the government organization in Asia. The other one is the Middle Eastern operation that had like, let's say, multiple objectives. And then the third one, just to see how generic this tool is, it was like a standard web defacement. If you have an attacker and you compromise one application on a web hosting system, then you can, if you get the writing privileges, you can change all the home pages to display something. So very wide range of people using it. And the first case is the cyber espionage. And so in this case, these guys are using a particular version of RAR archiver with quite a complex password, and every day they are running this particular set of tools. So this is a government organization, and in the home directory they're collecting all the doc files, the PowerPoint files, the Excel files, a number of different types of documents. They are archiving them into the output directory, and then they're moving them in another system within the network, which they will probably use to kind of exfiltrate. The other, on the same system, we saw potentially 2 groups. One that used renamed WinRAR, and the second one that used RAR, standard RAR, with always the same password, and that password was son of a bitch, I think. So and that's why we didn't. That's why I didn't put it here. But it's a bit of a kind of profanity, and so we could recognize when these actors were kind of trying to encode the data. They were also interested in the database code. So again, remember, there's always some kind of PowerShell. Here we see a PowerShell that's added as a parameter to the Microsoft build executable. And what this does is simply, when it gets a script file that's encoded and dropped on the disk, it gets the key to decrypt it. And then once it's decrypted, it adds it to the set of PowerShell scripts, and it executes it. So it kind of hides the code on the disk. It also has 3 distinct user agents that are used. So one of them is chosen by kind of almost by random, and then that's used to download some of the additional scripting data. And once they downloaded this data, they download it into the module called helper.ps1, and that helper is basically just a SQL module that allowed them to connect to the SQL server, where they know they wanted to dump some kind of data, and they dump the data from the database, and then they use just like they mounted a remote share on a remote disk, and then copy that on that different system. So this is like a typical exfiltration case of probably 2 different groups, and we contacted those customers, so they dealt with this issue. But the interesting thing is that all of these the campaigns, like 3 that we are investigating, are lasting for over 10 months each. So if you think that the compromise can be easily detected, that's not necessarily true, because these guys were successfully doing it for like over 10 months, for a long time. The second campaign has multiple goals and installs some remote administration tools in this case, or just like your regular ransomware malware. Again, we see some of the PowerShell code that are using pastebin.com, and in this case it's a ransomware family called Sodinokibi or something like that. So again, they have the same idea. They use the reflective DLL loader. So anything that's hosted on pastebin.com is the actual code that's almost the same as the legitimate reflective DLL loader, but they only replace the binary part that's loaded in memory. So I mentioned that they have multiple goals, so we kind of stumbled upon this standard malware, but they also were trying to dump the credential by downloading invoke mimikatz and pass the hashes. And then once when they manage to create those or retrieve the credentials, then they will create new user accounts and they will try to enumerate all the other systems in the network and then go into Active Directory. And then from then on, I kind of lost track a bit, but it was enough to decide that this is like a multi-prong type of campaign. And the last one is the web defacement. Here again, I looked at about 6 different servers from an Asian web hoster. 6 of them had some kind of China chopper activities, and maybe only 2 of them had something that can be considered like interesting or serious. So in this case, we see PowerShell again code that's loading something from the Windows Management Instrumentation database, which is the registry, and decodes that and runs that code. So this is probably some kind of fileless type of malware that's hiding its code in this database. It's not on the disk as a file, but it's run by this short piece of code. The second one, again, our favorite is mimikatz. And again, you often see mimikatz in legitimate and illegitimate activity. So these guys are trying to invoke mimikatz and then save the passwords in a file and then reuse those passwords. Finally, we see that the attacker is invoking cackles, which changes the access control lists on the directories which are used to host all of the websites for these web hosting providers, and allows full access to all of the users. So when they allow access to all of the users, then all bets are off. You can change anything. But luckily in this case, it wasn't very serious, and I took this screenshot from zoneage.org. Is one of the IP addresses that was compromised, and by this China fans group, I guess, you know. So again, we see China chopper from web defacement, simple stuff, not very serious, to something that's potentially very serious, and that's stealing and exfiltration of confidential documents from a government organization. So we talked about leaving of the land binaries, how attackers are trying to misuse them, how often they misuse them. We've seen some of the interesting cases, or let's say more interesting cases. So how do we detect or how do we protect ourselves from it? If we are working in I come from more of the kind of defender side, so I'm always interested, like, how can I detect this? So within your organizations, if you work in a security, then if you're not already doing this, then you can centralize the logging. So logging of the various types of events, such as process startup and termination. Everything you can set a policy in Windows, and you can allow that to be logged in the centralized logging block, including the executed PowerShell blocks. So you can instruct PowerShell engine to actually log every single PowerShell block. So anything is between the curly brackets will be displayed in the log. So if you're a security person and if you're an analyst and you see that suspicious blocks are coming into your SIM tool or whatever you're using to aggregate the log files, then you want to investigate. If you can, try to prevent PowerShell invocation at all, because if you know that you don't have to use it, then simply just block it or remove it from the system. Or allow only non-good command lines. So try to enforce only the signed scripts to be executed, but try to block anything else. And also when you look into the kind of network security, make sure that, or think about so-called zero trust approach, where essentially you don't trust anybody internally as well as you don't trust anybody externally, and you protect all of these important assets by some kind of second factor authentication or require a new login. We should make this sort of pivoting around the network using living on the land binaries more difficult. And of course, because you have that data, you can do more or less the same thing as I did, which is to conduct hunting activities, and you have like a parties, order pizza, and try to find what's happening on your network. So at the beginning I had the questions, are these binaries legitimate tools or the weapons of mass compromise? And I could just say, well, yes. They are absolutely misused by the attackers. From the commodity malware to APTs to red team exercises, you could see that they're being used. Nevertheless, they're still predominantly used for legitimate activities. And if you look at the trend so far, it's been on an increase, and it's likely to continue with more applications being discovered and misused. And with that, I think I'm more or less done on time. I'd like to thank you for listening to my presentation and my work, and if you have any questions, I'm very much open to any questions.
Unmute at the bottom.
At the bottom, yeah. We need an expert.
Press the button. Yeah. What tools do you use to deobfuscate PowerShell or JavaScript?
For the obfuscation of PowerShell, I'm using PowerShell. so what I do, I have a setup in a virtual machine. So if I execute something bad, so what I do then is I basically use Microsoft Code as the environment, which has the PowerShell plugin, and so from then on it keeps the context and the state as you run scripts. So basically, instead of invoke execution, I change that piece of code in obfuscated script, if it's with invoke obfuscation, to go into out string or out file. So every next stage I'll get the next stage, so I'll modify it next time, and as long as I get to the when I get the actual code, I go, that's it now. But it's not always easy. Sometimes it's completely unreadable. Then I use some of our sandboxes. I just submit that file to the sandbox and hope I'll see some activities from there. It's not always obvious which part of script you need to modify to get to the next stage. Or the scripting logging as well. The virtual machine has the blocking of script blocks, and then then can be already too late. I have to restore the virtual machine and so on. So it's easy to modify and be safe. Yeah.
Nice.
In your research, have you encountered some malicious activity that is actually coming from Serbia? Are there Serbian hackers, or everything is just Chinese, Ukrainians, and so on?
Unfortunately, I don't have that particular data. So what I have is, like I said, I have this sort of unique organization ID. I have unique things. So I can, from some of the content, see more who the victim is than the attacker is. So in case of this Slovenian guy, I could see that they're using Slovenian host for infrastructure, that the name for the email address is a Slovenian name, therefore most likely it's somebody who's from Slovenia. And when I looked at the organization that was affected, it was an organization from Slovenia. So for me, it's like I connected those dots. But I can't always see. I can really look more at the infrastructure rather than, I don't see the IP addresses that much. We have a set of IPS rules. the program. So not all of the Cisco's product will report telemetry to us centralized, because there are a lot of government organizations they don't want to have any kind of telemetry in, and big companies. So I get it from the Cisco has this product line called Meraki, and so Meraki has a limited subset of IPS rules, and there I get the detection names plus the IP address of the attacker and the actual IP address of who the attack system was. But then again, how can you know, even if the IP address is located in Serbia, that doesn't necessarily mean it's a Serbian actor.
Maybe some traces that point to actually Serbian Balkan origin.
Yeah, it's something that I wouldn't say kind of it's not, we are not struggling with that, but often we would like to know more, and we can't know. So that's why some of the information is, I have to connect some of the dots before I can say something, and
thank you.
It's tricky. Any more? Well, if there are no more questions, as I introduced myself, I will say goodbye to myself and to you, and thank you for listening. Thanks.